In this video, we will be looking at nucleon number and atomic number specifically for EDEXCEL. Specification point 130 states that we need to understand what is meant by nucleon number and atomic number. Since this topic regards atoms, we need to understand, well, what do atoms consist of? Atoms consist of subatomic particles known as protons, neutrons, and electrons. Within the nucleus of an atom, protons and neutrons are located, and around the nucleus of an atom within energy levels are where the electrons are located. This is represented in the following diagram below. So as we can see, within the nucleus there are protons and neutrons, and those circular lines around the nucleus are the energy levels where the electrons are present. Now, we need to look at the definition for both nucleon number and atomic number. Nucleon number, also referred to as mass number, is defined as the total number of protons and neutrons in an atomic nucleus. The atomic number, also referred to as the proton number, is simply the number of protons in an atom. There is also a third thing that we need to consider, which is atomic mass. Now, I know that sounds very similar to mass number, however, it is very different. Atomic mass is the mass of a given atom, usually expressed in atomic mass units. It is the atomic weight of an atom multiplied by the atomic mass unit. So let's take boron as an example. The atomic weight for boron is 10.811 multiplied by the atomic mass unit U, which is 10.811 U. The atomic mass unit has many conversions. As an example, one atomic mass unit is equal to 1.66 times 10 to the negative 27 kilograms. That is generally the conversion that they'd expect you to use in EDEXCEL style exam questions. Now, since we've looked at the definition for both nucleon number and atomic number, we can put them into word equations, making it easier for us to understand. So the mass number is equal to the number of protons plus the number of neutrons. Now, if we would like to rearrange to obtain the number of neutrons, that's then equal to the mass number subtracted by the number of protons. Similarly, to obtain the number of protons, we just rearrange that equation again to give us the mass number subtracted by the number of neutrons. Now let's have a look at these following two examples. So nitrogen has 7 protons, 7 electrons. Provided that it has a mass number of 14, determine the number of neutrons. Well, the number of neutrons is equal to the mass number subtracted by the number of protons. The mass number is 14, so we do 14, and the number of protons is 7, so we do 14 minus 7 equals 7 neutrons. Now, if nitrogen has a mass number of 14 but 8 neutrons, then find the number of protons. So we simply just rearrange our word equation again. So the number of protons is equal to the mass number subtracted by the number of neutrons. The mass number is 14, the number of neutrons is 8. We do 14 minus 8, that equals 6. So we end up with 6 protons. In an electrically neutral atom, the number of electrons is the same as the number of protons. If an atom has different number of electrons than protons, or vice versa, it is considered an ion, with a net charge being either positive or negative. So let's have a look at these following 3 examples. Atom number 1 has 5 protons and 5 electrons. So the net charge is going to be equaling 0, therefore making this a neutral atom, since the relative charge on a proton is +1 and the relative charge on an electron is -1. Since a single proton has a +1 charge, there's 5 protons, that's a +5 charge. And since the charge on an electron is -1 and there's 5 electrons, that's -5. Combining those two charges, +5 minus 5 would equal 0. Now, atom number 2 has 5 protons and 7 electrons, so the net charge is -2. Therefore, this atom is classed as an ion due to having a net negative charge. Atom number 3 has 6 protons and 3 electrons, so the net charge is going to equal a +3 charge. This atom is also an ion due to having a net positive charge. Now that we have understood the concept of nucleon number and atomic number alongside net charge, we can apply that to these 2 questions. So it says fill in the missing table. We are given the number of electrons, mass number, and net charge, and we need to find the number of protons, neutrons, and atomic number. We can form a new word equation with the net charge equaling the number of protons plus the number of electrons. We can rearrange that word equation to give us the number of protons, which equals the net charge subtracted by the number of electrons. So the net charge is -4. We need to subtract that by -12, not just 12, but by -12. The reason being is because on an electron, on a single electron, the charge is a -1 charge. We have 12 electrons altogether, so it's a -12 charge. So we do -4 minus -12, which equals 8. So we've just determined that the number of protons is 8. Using our other word equation that we obtained, we can rearrange to get the number of neutrons. So the number of neutrons equals the mass number subtracted by the number of protons. The mass number is 16, the number of protons is 8, therefore that means the number of neutrons equals 8. And the atomic number is the same as the number of protons. So the number of protons altogether is 8, the number of neutrons is 8, and the atomic number is also 8. Now question number 2. This time round we are given the number of neutrons, we're given the mass number, and we're also given the net charge. So if we want to obtain the number of protons, we need to rearrange that word equation to equal mass number subtracted by the number of neutrons. Well, the mass number is 25, subtracted by the number of neutrons, which is 15. So we'd end up with 10 protons overall. Now, if we look at the net charge is -6, and we have 10 protons. So that means that there must be 6 more electrons than protons. Therefore, the number of electrons must be 16. So we have now obtained the number of protons, electrons, and the atomic number is also the same as the number of protons. So we have 10 protons, 16 electrons, and 10 for the atomic number. Thank you all for watching this video. I hope that it has made sense and cleared any questions anyone has had about nucleon number and mass number. Please like, subscribe, and share, as this would be greatly appreciated. Thank you for watching, and goodbye.